Welcome to the project proposal presentation for the Smart Pet Rescuer.
Nearly 100,000 pets were abandoned after Hurricane Katrina. The cat catcher aims to reduce the number of abandoned pets after disasters. Rescuers can place the cat catcher where it is needed and will receive a notification and image of the cage as soon as the trap is stripped. Here we have a few of our use cases. The first use case is the rescuer setting up the cat catcher for use. The rescuers will sign into the cat catcher application, connect the device to self-service, and enable notifications from the application. The rescuer will then place the device in the capture zone and add cat food to the cage. Finally, they will request pictures from the application to verify that the device is properly set up. The next use is the cat being captured. The cat will be lost in a disaster zone where they will smell food and wander into the cage. From here, the cage door is tripped and a notification is sent to a rescuer of the tripped cage. The final use is the rescuer retrieving the cat from the disaster zone. The rescuer will receive a notification when the cat has tripped the cage, and they will verify that the cat is in the cage by viewing an image. After verification, the rescuer will retrieve the cage from the disaster zone and reunite the cat with their owner.
Moving on to the key requirements of the cat catcher. It is assumed that self-service will be present in the area, and before placing the cat catcher in the disaster zone, the rescuer needs to connect with it via the application in order to receive notifications and other updates. The camera monitoring the cat catcher will be placed on a motor which will rotate and stop at certain degrees momentarily for the rescuer to watch for movement via the application. There will be a limit switch which will be triggered upon a cat entering the cage, and the rescuer will be notified about that via email. The rescuer will have the ability to view and take pictures of the contents of the cage via the application. All the electrical equipment, including the Raspberry Pi, the camera along with the motor, and a portable charger, will be placed in a 3D printed case which will be attached on the inside of the cage. This placement of the equipment will protect it from any rubble or water around it. In the event of a false positive, the rescuer must approach the cat catcher and in order to open the door again. On the other hand, in the event of a false negative, there will be enough food for the cat to prevent it from starving. The rescuer will still have the ability to check on the cat catcher via the application, and the rescuer will be notified again if the response from the rescuer or the user isn't received. The portable charger will be utilized to power on the Raspberry Pi and the camera. It consists of a high quality lithium polymer battery which protects the devices from excessive energy consumption and overheating. The battery, when fully charged, can keep the devices powered on up to 3 days.
Here is the Gantt chart for our project. The first phase of our project will be the CDR. Starting on September 21st, we will work for 17 days, finishing designing all the components for our project, creating a CDR presentation, and then also creating a CDR report. After the CDR, we will then start our prototyping phase. We will have 12 days to prototype all the parts we need. So we will prototype a platform for the camera, a cage closing sensor, and we will also create an app for updating the text list and a program to send text from the Raspberry Pi. After prototyping, we will go into our final build phase. For our final build, we will have 21 days. During those 21 days, we will work towards building the final platform for the camera and building the cage closing sensor. We will then combine those two together onto the cage, and we will also combine the text and app programs. After the final build is done, we will do some product testing. We will spend 7 days to complete user acceptance tests, and then we'll have an extra 7 days to fix any bugs or errors in our product. After product testing is done, we will then prepare for the demo by creating a presentation for the demo and then practice giving said presentation. Here is our CPM for our project. The critical path for this project starts at the beginning and then goes through the design camera holder, which will take 10 days. Then we will go through prototype camera holder, which will take 12 days. Then we will build camera holder, which will take 14 days. Then combine all parts for 7 days, test product for 7 days, fix bugs and errors for 7 days, create the PowerPoint demo for 7 days, and then practice for demo for 7 days. This will take a total of 71 days.
All right, moving on to plan of work risk mitigation. First, we have two high priority technical objectives. The first is connecting the cage trigger to the tech service with high reliability. This means that we want our cage to work consistently when an animal does trigger it, and we want no false positives or false negatives to distract first responders. Additionally, the second objective is to expedite deployment of the cat catcher for use in time-sensitive environments. This basically just means that ensuring that it's easy to set up and that first responders don't have to spend a lot of time worrying about making sure that it's going to work. Moving on to the resilience strategy. While a lot of our team has hardware skills and some software skills, our biggest weakness is that only one team member has a lot of experience with front-end development. We plan to mitigate this by having two team members work on front-end development at all times in order to ensure that if one of the team members drops out, the other one still knows what's going on. Additionally, we also plan on to meet consistently and to reassess our commitment to the project so that we know if anyone is planning on dropping out.
User-oriented tests will include easy to set up and deploy in under 5 minutes, able to connect to a cat cage via an app or similar device, receive user-accepted notifications that a cat cage was successful during setup, user to receive also an automated message when the trap is also triggered by a cat. We have some non-user oriented tests to be able to operate remotely for a defined period of 3 days, able to operate in a varied temperatures and water resistant, able to handle verified false positive results and give accurate feedback. Camera should also be able to rotate and take pictures of a captured cat and or immediate surroundings. The Cage Raspberry Pi will also be able to auto-connect to a web service to be able to send notifications to the user.
All right, in summary, we aim to create an easily deployable cat catcher for use in natural disaster areas, and we hope that this project will aid in the rescue of displaced pets. We aim to finish a prototype by December. Please let us know if you have any questions, and we hope you enjoyed the presentation.